Thank you for listening to this last presentation for streams and running water and rivers and running water. All right, teaching point, please get this down into your notebook. How can a landscape affect the movement and direction of running water? Again, how can a landscape affect the movement and direction of running water? Launch for this, how do you think a youthful stream differs from an old age stream? All right, so we can think about this with respect to age, right? So right now, all of you are youthful, right? You're young, you're energetic, right? Unless you have some problems with your metabolism, right? Then you won't have a lot of that energy. All right, some of your classmates is learning about however you learn about metabolism, and sometimes people are very tired because they can't break down certain foods or they have problems with taking in oxygen, right? So you definitely have some curveballs there, but for the most part, you're youthful, a lot of energy, right? As you get older, right, you step into my shoes. As you get a little bit older, your energy begins to dissipate, right? And you get really old, right? Your hair turns a different color. You might be balding. You're probably shrinking in size, right? Your bone density is decreasing. You're not full of energy anymore as much as you used to be when you were younger. Streams do the same thing, all right? And also, let's go back to unit number 2, stars. When stars are born, a lot of energy, right? They're in the main sequence, which is the first stage, right? The most youthful portion of the star. And once the star leaves the main sequence, right, then it's in the process of dying out, right? That means that the energy, it can produce a lot more energy because the fuel, hydrogen, is abundant and scarce around the formation of that star. All right, so with respect to streams and rivers and creeks and brooks, youthful, fast flowing energy, right? Old age, very slow, right? Sometimes when you get older, you might need canes and walkers, and you're walking very slowly, right, in life. So these rivers that are old age or have the old age designation means that they're flowing slow. And we can think about a lot of factors involved that can make this happen. As a matter of fact, you had one video where I told you about this whole sequence. All right, running water. Compare and contrast between these pictures below. All right, so let's compare and contrast these. All right, let's go with some comparisons. Right, first comparison, of course, is going to be that each of these three pictures have some sort of running water to them. All right, so there's a similarity there. Some contrasting points is that um, we have some whitewater rapids here. And this is a great picture, a great shot of people whitewater rafting. You need a lot of protection. Sometimes you can get shot out of your raft, and that's why everyone's wearing helmets. So more than likely, because they're wearing helmets, uh, these rapids are probably going at least maybe class 4 or class 5 rapids. Class 5 is your most intense rapids that you can have. Here we don't have too much of white water. Here, even though this is kind of far out because I want to show you the aerial view, we don't really have a lot of whitewater rapids here because the velocity is not going as fast. Here, velocity is not going as fast, but here the water velocity is going really fast, especially over the land below it. Now, the land below it can have a lot of boulders and other size sediments here that can raise the water up a bit to give you a lot of this white water. All right, let's get this down, please. Youthful stage. Newly formed stream that flows down steep slopes. Steep slopes, steep gradient. Steep gradient, faster flows. Faster flows, more erosion. Yeah. Common in mountainous landscapes. So in order to get these steep gradients, right, you would have to have a very steep, well, semi-steep slopes. You can't really have cliffs unless you're going to. I mean, that's a vertical drop right there, right? If it's going to flow, you have to have some sort of gradient that's going to be less than 90 degrees, right? 90-degree angle between the surface is basically a cliff. Flows quickly, you're going to have whitewater rapids, and that's really fun. If you've never gone whitewater rafting, that should be put on your bucket list, ladies and gents. You should definitely do that at least once in your life. So much fun. Erosion is dominant. All right, so you're going to have a lot of erosion happening here, very little amounts of deposition. We see a meander here, right? Little meander. So maybe it's flowing a bit more faster on this side. That's the outside bank. A little bit slower on this side. You may have a little bit of deposition, but for the most part, erosion dominant. This is going to downcutting the earth into V-shaped valleys. All right, and here's what we mean. Downcut into V-shaped valleys. All right, this is a great example here. I like this first picture. All right, so as the water flows, right, it begins to help break down and erode sediments away. So you can downcut the earth into this V-shaped valley. This one's another good one too. All right, so fast-moving water here can definitely downcut this right into a V-shaped valley. You have a valley that's happening here. It might get a little bit wider, but this water is still downcutting, right? You still can produce a nice V-shaped valley there. So we have all these movements of water. All right, next one is mature stage. Right, in the mature stage, aka teachers like Mr. Rankin, right, more shallow slope than youthful stage. All right, so the slope or the gradient lessens a bit. Slower velocity, which will result, slower velocity can result in some deposition. Begins to meander as the moving water flows around obstacles. So in this picture here, this is more of a mature picture. It's beginning to meander. We don't have a lot of meanders, right? But it's beginning to have your curves as it goes around these obstacles. Now, obstacles mainly can be some rocks that can't get broken down as fast. Maybe it's an obstacle of like trees and other materials in which those root systems help anchor the soil in place. Very hard to erode that. We have a thing called dynamic equilibrium, right? Dynamic equilibrium. Now, equilibrium means a balance. So we have the word dynamic means active. A antonym for dynamic is static. So when things are static, we're not talking about a lot of movement. Dynamic is moving and changing. So we have this balance, this active balance between erosion and deposition. So in places where it's going to erode because it's beginning to meander, you're going to have deposition on the insides, right? Erosion, deposition. Erosion, deposition. Erosion, outside bank, deposition, erosion, deposition. Right, here's a pretty big meander, right? So erosion, deposition on the inside. And that will continue all the way until it gets to its lowest level. And what can be the lowest level? Old streams and rivers and brooks and creeks. Eventually go into, I'm going to say rivers, right? Because that's what they kind of are at that point. Right, the lowest level it can go to is the ocean. All right, so interesting fact here about the meanders. So we have a thing called oxbow lakes, which I'll have on my next slide. I'll show you a definition. An oxbow lake gets its name from the U-shaped collar placed around an ox's neck, right, to which a plow is attached, right, to help plow fields. It can also be called a horseshoe lake, a loop lake, or a cutoff lake. All right, the regions, we like to use the word oxbow. All right, so we use oxbow lakes here as that shape. Old age. Now, in old age, it's going to move very slow, which means the gradient has to be less. So we have an extremely shallow gradient. Very little gradient. Because it's very shallow and very low, we have very slow moving water. We have many meanders, right? In this picture, there's so many meanders going downhill. Water has to flow downhill, so there's still a gradient, but not as steep as it was for the mature or the youthful. Frequent oxbow lake formations and deposition is dominant here. Once this begins to slow down altogether, we're going to have a lot of deposition in this last sequence. All right, Great Oxbow Lake. This is a time-lapse video. All right, so there's a river in Peru. We have a lot of outside meanders, right, which means that the outsides are going to erode. The insides are going to deposit. So these, look, outside, they're going to erode, and over the course of time, they're going to get closer and closer together. And water wants to water's lazy, takes the easiest way, and the easiest way then is to go nice and straight, and to avoid this loop, that is your oxbow lake. And we have the formation of another possible one happening here as these two meanders come closer together. And eventually they will come together, and then you will have another oxbow lake happening here. All right, pretty cool. All right, oxbow lake, where a river meander becomes isolated. Where a river meander becomes isolated. All right, looking at your key, here's a sequence of events to lead to your oxbow lake formations. The triangles is erosion, and the dots are deposition. So erosion means it's going faster. Deposition means it's going slower, right? It's able to deposit. And we can see all these triangles on the outside of the meanders. All these dots are on the inside of the meanders. These two are going to come together here after many years of erosion on the outside banks. And once they get close enough and they touch, it can become a bit more straighter. A new course for this river will happen, or stream, and it's going to cut off, it's going to isolate this meander. And that's called an oxbow lake. Now, these oxbow lakes can disappear because of a few reasons, right? One main reason is you have a lot of evaporation and very little precipitation, right, to help replenish that, right? The water table also plays a role in keeping the water in these lakes. So if the water table drops down past where this down cuts into the water table, if the water table drops even lower, this whole entire lake will disappear. It will reappear once the water table increases in height and begins to intersect the valley of that meander. Oh, this is probably good. Let's check out this one. All right, so in this picture, we have, looks like two portions. Okay, one portion of the water table, we have a capillary fringe in which the water can go upward against gravity, depending on the size of those sediments. All right, but right, the water table can intersect, right, this stream, right, this stream valley. Where it intersects will help you understand where the water table might be. Well, this one's even better. Here's your aquifer. Your aquifers, you'll learn more about this in college. The aquifers is basically your zone of saturation. So this is your zone of saturation. That's your water table. Notice how it intersects, right, the down cutting of this river. So your water table can highly affect the level of water that's inside standing water, as an example. This here is standing water. So if your water table drops past the area where it's down cut from the erosion, then this will eventually disappear. Again, it can reappear once the water table goes up, and it can help replenish some of that water that was once there. All right, here are the stages of a UFO stream, right? We have mountainous landscapes. Right here we have some snow-capped mountains. We have glaciers. We also have ablation happening at the base of these glaciers. Gives you a lot of meltwater, right? Called outwash. You have outwash in here. You have rain and precipitation. That's going to give you an increase in velocity. A lot of erosion happening here. Over the course of time, the gradient will lessen, become less steep. You begin to have meanders, right? Moderate slopes. And then at your lowest level, where it's going to go, you're going to have the most gentle slope, or the most gentle gradient, in which you can have a lot of meanders. Some oxbow lake formations will happen. And eventually, all of this will discharge into the greatest basin of all. And the greatest basin of all is the ocean. And that's your stages. Young, youthful, mature, and old age. All right, last one here. Explain the differences between type 1 and type 3 stream channels. Indicate that the average velocities of the streams are different between type 1 and type 3. All right, so I'll leave this up here. All right, we're concerned with type 1 and type 3. Pause the video, think of an answer. Once you have your answer, hit the play button and listen to me give you a nice detailed answer. Okay, so we can see that type 1 and type 3 are really different. Type 1, we have a straight channel, right? Narrow V-shaped valley, right? Narrow meaning the floodplain here is pretty narrow. You have a wider floodplain happening here, right? And a moderate floodplain happening here. Since this is a straight channel, and this one here has a wider channel has a bigger floodplain. and you have this channel is meandering a lot. That can help us figure out that type 1 has to be youthful and type 3 has to be old age. We do have oxbow lake formations happening here. We do have some natural levees around here that try to help retain some of that water from overflowing its banks. So type 1 would have a steeper gradient, faster flows. Type 3 would be a slower slower velocities and a lower gradient. I explain how the differences between type 1 and type 3 channels indicate that the average velocities. Okay. And the last thing here is that since this is going really fast, it's going to downcut these V-shaped valleys a lot more. Here we don't have a lot of downcutting going on, and it's very curvy. Right, and that can help us figure out that we have differences in velocities and differences in gradient. A lot of erosion, deposition dominant. Even though you have outside banks, which flow faster than the inside banks, you're going to have a lot more deposition here than type 1. All right, after this lesson, please answer a few questions pertaining to this lesson. If you have any other work for science class or other work from other classes, you can certainly do that. Have a great rest of your day, and thank you for listening.